Hello students, welcome back again. In this part we will discuss systems of SHM, the special cases, time period of a hydrometry along with time period of an LC oscillations. So let's begin the topic. Let's begin with the topic SHM in an electrical system. So already we discussed the case of SHM of spring mass system, simple pendulum. Now we will switch to the next topic in electrical system. When we have a series phenomena of inducting coil along with a capacitor. So we need to find an inductor L is connected across a plate of capacitance C. The force equation become the voltage equations. So we would like to discuss here the growth of potential across the coil is just equal to the discharge of capacitance. At a moment, energy stored by capacitance would be equal to energy stored by the inductor. So we can write here the equation of SHM or equation of voltage, that is L into d2q upon dt square plus q by c. We are knowing from where we got this value. Actually, we are knowing voltage across inductor plus voltage across capacitor should be equal to 0. We know that voltage across inductor is actually L into di by dt plus, that is Vc. Vc is equal to q by c, that is equal to 0. We know that q is equal to I into t. So on differentiating this relation with respect to time t, so we are getting d2q by dt, or we can say dq is equal to I into dt. So if we divide the relation with the respect of this, or in other terms we can say, means we want to differentiate this relation. So I equal to q by t, we will put here L into d into q by t, differentiation of this term again, plus q by c, and finally we will get L into d2q by dt square plus q by c is equal to 0. First of all, we need to write the equation of electrical system. Then we would like to put it in terms of single variable, that is charge. Now we are getting, in the absence of resistance, the energy of an electrical system remains constant. The sum of energy across inductor plus energy across capacitance would be equal to constant. So exchange between magnetic field energy stored in inductor and electric field energy stored between the plates of the capacitor. So finally we are getting V is equal to minus L di by dt, that is equal to L d2q by dt square, where I is the current flowing and q is the charge of the capacitor stored. So finally we are getting the equation says the voltage across the capacitor is q by c. So according to Kirchhoff law, d2q by dt square plus q by c. When we compare this equation with force is equal to mass into d2 x upon dt square is equal to the condition omega square into x is equal to 0. So on comparing this equation with the restoring force equation, we get d2q upon dt square plus omega square into k. So we are getting omega square q of this value, that should be equal to L by c. So finally we get omega square equal to 1 upon L into c. Omega is equal to 1 upon under root of L into c, or we can say 2 pi by t equal to 1 upon under root of LC, or we can say time period is equal to 2 pi under root of L into c. So time period in case of series inductor and capacitor oscillating circuit that resonates with the frequency 1 upon 2 pi on 1 upon under root of L into c. Now we would like to discuss SHM in hydrometry. In case of this, SHM of hydrometry mechanical system, liquid of density rho with small displacement x. So when it gets small fluctuations, it starts oscillating about the mean position. So net displacement occurred is equal to 2x. We know that restoring force is equal to pressure into height. So that is equal to pressure upon area. So pressure into area. So we know that rho into g into net displacement, that is equal to 2x. Or we can say m into restoring acceleration, that is equal to rho into g into 2x. Actually the nature is m into d2x upon dt square, that is equal to rho into g into 2x, or in another terms we can say m into omega square into x negative value is equal to rho g into 2x. So we know that density is equal to mass upon volume, or we can say m is equal to rho into the net fluctuations x into area. So on substituting this value over here, we will get the final relation as rho into L into d2x upon dt square plus twice of rho gx is equal to 0. On comparing this equation with omega into omega square into x is equal to force of restoring. So finally we get omega square is equal to 2g by L. So actually our approach should be to calculate the net restoring force. It is due to the pressure difference at 2 points. So pressure difference at point A and B is actually means pressure is equal to force upon area, or we can say pressure is equal to delta P equal to rho into G into 2x finally at some height A to the height B, and that should be equal to the restoring force multiplied by the area. Substituting this value in the main equation, finally we are getting omega square is equal to 2g by L, where g is the gravity, L is the length of the stem we have. Now it is just a frictionless U-tube of liquid. So finally we are getting time period in the case, that is 2 pi into frequency whole square, that is equal to 2g by L. So now we would like to discuss the example in more. Now in this example, an object of mass m 50 gram. So given data, first of all, that is m equal to 50 gram, is connected to a spring with a force constant, so K is equal to 35 Newton per meter, oscillates on a frictionless horizontal surface with an amplitude of 4 centimeter. We have to find first part, total energy. So total energy is actually 1 by 2 m into omega square into a square, or in other terms we can say k into a square, where k is the spring constant. 1 by 2, the value of k is considered to be as 35 and amplitude is given as 4 centimeters, so 4 by 100 square. So we will solve this mathematical lesson, we will get final answer for question A. Now question B, the speed of the object when the position is at 1 centimeter. So we know that total energy remain constant, but the redistribution of energy take place from kinetic to potential, potential to kinetic. So in the part B, we would like to discuss potential energy at any moment, at any time x should be equal to kinetic energy. So that should be equal to 1 by 2 kx square, that should be equal to 1 by 2 mv square. 1 by 2 would be cancelled out. Finally we are getting k x square by m, under root of this value, that is v. So substituting the values, that v is equal to under root of k is 35, x is given as 1 centimeter, so 1 by 100 whole square, and the mass is given as 50 grams, so 50 divided by 1000. Solving this mathematical equation, we will get the value of velocity v. Now part C. Part C is associated with the kinetic and potential energy when the position is 3 centimeter. So means kinetic and potential. So we know that kinetic energy is actually 1 by 2 m into v square. So mass is given, but we have to find out velocity at point 3. So we know that v is equal to omega under root of a square minus x square. X is given, a is given, and v is given. So we have to find the value of omega. Omega can be calculated from the value, as we know that t equal to 2 pi under root of m upon k. So we can say t upon 2 pi, that is equal to 1 upon omega equal to under root m by k, or we can say omega is equal to under root of k by m. So the value of omega would be calculated from this part, and we will put this value in the main equation. A is given as 4 centimeter, x is given as 3 centimeter, so we will calculate the value of v on substituting in the main equation, that is k equal to 1 by 2 m into omega square a square minus x square. So in this way we will get the value of kinetic energy. Now potential energy, we know that is equal to 1 by 2 kx square. So k is given the spring constant, x is the displacement at any time. So in this question actually we are about to discuss kinetic, potential or total energy at any moment. As in the first part, total energy of the system. Total energy of a system is equal to 1 by 2 k into the amplitude square. Part B, the speed of this object when the position is at 1 centimeter. So when the value of x is equal to 1 centimeter, the speed of the object, so speed of the object v equal to omega under root a square minus x square. So a is given, x is given, so omega can be calculated from the relation we discussed at the top, that t equal to 2 pi under root m by k, omega is equal to under root k by m. K is given, mass is given, put the value and we'll get the value of speed. Part C, kinetic and potential energy when the position is 3 centimeter. So kinetic energy is actually 1 by 2 mv square. Already in the part B we calculated the velocity. So kinetic energy is equal to 1 by 2 k, 1 by 2 mv square. Mass is given, velocity already calculated. We put the value and get the answer. Now in case of potential energy is just the energy associated with position of any object. It's equal to 1 by 2 kx square. K is the spring constant or force constant, x is the displacement at any time. On substituting the corresponding values of these two terms, we will get the value as 1 by 2 kx square. Hence, we got the answer for all the three questions. As in this part, we discuss about system of SHM of a hydrometry along with LC oscillations. I hope you are enjoying. Now, in the next part, we will discuss about superposition of two SHM when they are in same phase or opposite phase. So stay tuned with us.